Hello, calculus fans! Alright, so we've done quite a bit of work discussing the first and second derivative and how they influence the shape of graphs. We're going to continue on and talk a little bit more about this and some theorems that will help us to draw these graphs more efficiently. I want to start this section with a theorem that will be useful for a variety of different things, most notably for proving some of the theorems that we're going to be talking about later. Okay, this is the mean value theorem, which says that if you have a differentiable function on an interval a to b, then there is some number c that's between a and b that makes f prime of c equal to f of b minus f of a all over b minus a. You can write an equivalent statement. The equivalent statement might look something like this. Now I'd like to show you a picture just to convince you that it's plausible that this theorem is true. So the idea is that the right-hand side of the equation that we talked about up here, that's the slope of the secant line. So in both of these pictures, that's the slope of the blue line that you see. And then the left-hand side, this guy here, that's the slope of the tangent line. So what the mean value theorem is saying is that there's some number c that's in between, that's in this interval here, where the slope of the tangent line will equal the slope of the secant line that joins the 2 points on the ends. As you can see in the second picture, sometimes you get multiple values of c that works. The mean value theorem doesn't guarantee anything about that. It only guarantees the existence of at least one such number. All right, so everything that we see here, what we have is that the slope of the tangent line is matching up with the slope of the secant line. In these pictures, the secant line, which joins the points A and B, is in blue, and then the tangent line is in red. The slope of the secant line is f of b minus f of a all over b minus a. Now, we can give an interpretation of the mean value theorem in the context of position and velocity. So if we have a function which is the position of an object, then we know that the average velocity of that object over the time interval from a to b is this difference quotient, f of b minus f of a all over b minus a. Now what the mean value theorem is telling us is that there's some time c that's in between a and b at which the instantaneous velocity is equal to the average velocity. So that's saying that the instantaneous velocity at some number c, which is equal to f prime of c, is actually equal to the average velocity over the whole time interval. Okay, that's all for now.